rainy day in June 2021, I made a day trip to the village of Stoke Cannon outside Exeter to meet a man called Derek Boustred. He collects rainfall from a rain gorge in his back garden. He measures how much falls each month and he records it for safekeeping in a kitchen notebook. Carrying on over the years, Derek and his late father have so far between them collected 44 years of measurements. This is now an invaluable data record of the climate in the lower reaches of the River Culm, and also an inspirational story of how someone is putting citizenship science into action. I went to speak to him to understand what motivates him to take an interest in the weather and to show how easy it is to do something to help the environment, particularly your local river. So, this is you, Derek.
Thank you. I'm Derek Boustred. I've been part of the parish of Stoke Cannon since 1981-82. I've been a keen citizen scientist on and off since the 1970s, when I was involved with various marine projects with the Marine Conservation Society. We did everything from scallop surveys to seagrass, and it's seagrass that I'm involved with now. I'm part of a team that monitors seagrass beds in Tor Bay. We've also been involved with planting seagrass beds in Plymouth back in February, March. My interests in the Culm are from the point of view of the environment, in that we're very keen here in Stoke Cannon for the Culm to pass through us as quickly as possible and not cause any flooding. These days we've got a system of low banks that surround the village, which give us a 1 in 100 year chance of flooding. We had severe flooding in 2012 going into 13, when 21 properties were flooded and the occupants were out of their homes for almost a year. To help me with this side of our work in the village, we have a flood plan. We have a system of flood wardens. The flood wardens are basically neighbourhood watch. We keep our eyes and ears open for our vulnerable residents. And, if there was imminent chance of flooding or danger to life, we would be able to summon up immediate help via coordinators, who would then actually coordinate the rescue services to help people here on site. And we had a couple of rescues in 2012-13. My interest with connecting the Culm has been water testing in the lower Culm. We're quite interested with looking at water testing. We're concerned about likelihood of runoff. There's a likelihood of long-term storage of digestate here, which could have a severe impact on the Culm if left unchecked. So recently, since about January, I've been doing monthly data collecting, testing for turbidity, phosphate, nitrate, etc. So it's very much the early days. I won't say I'm an expert on the data by any means, but I'm certainly collecting it. The other data I've been collecting has been rainfall, which I inherited from my late father. I now measure, and have been measuring since 2006, every drop of rain that's fallen out of the sky, and this I log on an annual basis. From this we can look at trends. If we have 3 to 4 months of very heavy rain, there's a very high likelihood of flooding of some description. Not necessarily threatening life, but it's nuisance flooding, and certain roads will become impassable. So it's very important data. Our biggest worry here in Stoke Cannon is flooding of the Culm and the Exe together. And for this flooding to go over the low embankments that now surround the village, we have a 1 in 100 year chance of flooding. So we're a lot safer than we used to be, and it was only 1 in 20 back in the early 2000s.
Stoke Cannon is a small village and it sits on the River Culm just before it joins the River Exe north of the city of Exeter. The bus there turns through the beautiful catchment of rolling green hills and vistas of farmland peppered with small historic towns and buildings. I'm a placement student at the West Country Rivers Trust, and I was introduced to Derek as someone with long-standing commitment to the community he lives in. He's now involved in a project called Connecting the Culm, which is a successful and quickly growing initiative that's bringing local people together to take ownership of their river, to become environmental stewards, and also to steer their ideas and actions towards a collective vision of how the catchment could be better looked after, for the sake of both people and the environment. By collecting rainfall data, Derek is providing a snapshot of the climate on a local scale, which can be compared to other weather data in the catchment, and it contributes to a broader and more detailed understanding of what is going on in the River Culm as a whole. The data he's got can be analysed against the Met Office data to understand how the local microclimate compares to their weather station at Exeter Airport, and it may also be useful for predicting future events of flood and drought, now that there are more than 4 decades to analyse the patterns from. Understanding weather events can be used to help explain water quality measures being taken along the river by other citizen scientists too. In particular, I have been looking at the trends in Derek's rainfall data to better understand how climate change may have an effect on the lower reaches of the River Culm. There is evidence that the winters and autumns are getting wetter, whereas summer and spring are becoming drier. Also, that more intense and extreme periods of flood and drought are becoming more frequent. Taking these findings to discuss them with Derek, we agreed that this shows what is to be expected with climate change, and collecting more rainfall data over the next decade or so will contribute even further to our understanding of what is going on. The better we understand local climate changes, the better we can predict and manage the flood and drought events that affect our communities and livelihoods, as well as understand how it affects the flora and fauna that depend on the healthy state of the river. When I arrived in Stoke Cannon, I met Derek for a chat, and I asked him a couple of questions I'd written down. Can you tell me a bit about yourself? Derek spends much of his time volunteering for a number of different projects. On my visit, he talked about his current volunteering for the Nationwide Association of Blood Bikes, which involves driving his motorcycle across various places in Devon during the night time to transport important samples and medicines between patients and NHS centres. Another passion of Derek's is his involvement in the restoration and planting of seagrass in Torbay Harbour. He showed me the maps of the extent of the work achieved there, and he explained how his involvement with the Marine Conservation Zone as a scuba diver and researcher has spanned more than 30 years. He was involved in the Living Coast marine wildlife attraction in Torquay since it opened in 2003, and he used his diving experience for tasks such as maintaining the tanks for the wildlife. Unfortunately, though, due to falling visitor numbers and worsened by the financial pressures of closure throughout the pandemic, it's meant that the attraction has now closed. In the future, the site might be turned into an open public space as part of a regeneration plan for the harbour, and Derek plans to remain involved in the conservation of the marine wildlife where it's possible. How long have you been collecting the rainfall data? Derek's father collected rainfall measurements since 1977, which Derek continued from the year he died in 1999. This means, between them, they provided 44 years of continuous rainfall data for the lower part of the Culm catchment. The first half of the data is collected from Crediton, 1977 to 1997, whereas the second half is collected from Stoke Cannon, the year 1998 to present, with a short gap in the early 2000s. There might be some interesting comparisons to draw between the different locations, which are approximately only 7 miles apart, and both short distance upstream of the point at which the last major tributary, the River Creedy, joins the River Exe. Where and how do you collect the rainfall data? The Rainfall Gorge is simply a metal tub on a wooden pole. It's stuck into the ground in Derek's back garden, and a funnel sits on the top of the tub to channel the raindrops into it. In these pictures you can see him using the Rainfall Gorge. Every few days he will walk out to it, he pours the water into a measuring tube to see how many millimetres have fallen, and records this in handwriting using a pen or pencil and a small booklet in his kitchen counter. At the end of each month, he adds this up to calculate the monthly total. Here's a photo of the booklet. The first column records which day of the month it is. The second column records the amount of rainfall in millimetres. The third column records the running monthly total. And the fourth column records the running yearly total. If it's been a particularly rainy day, Derek will usually go out to retrieve the water measurement that day. Each monthly total is copied over to a table, summarised by hand, simply drawn on a piece of paper, and he stores this in a ring binder for future reference. This was done by Derek's late father and continued by Derek so that this year all of the data could be entered into an Excel spreadsheet on the computer, and this has made it easy to do the statistical analysis with the numbers. Can you see the change in handwriting where Derek took over from his late father? If you look down the 1999 column, 4.27, the 4 is slightly different. Transcribing the numbers into Excel has made it possible to analyse the trends that we have seen over that 40-year period, and a few interesting things could be seen in the data. Firstly, the variability of the weather is changing over time. Here you can see the data spreadsheet for the town of Crediton from the late 1970s and through the decade of the 1980s. 1981 and 1984 were particularly wet years when a lot of rainfall fell, but apart from that, we see steady annual figures of between 800 to 900 millimetres of rain falling each year. When dry months occurred around late winter and springtime, it resulted in the occasional dry years of 1978, 85 and 89. Looking in comparison at the next spreadsheet of data for the 1990s, the total annual rainfall appears more consistent within the 800mm range of rain falling each year. 1993 and 1994 were notably wetter years overall, but as you can see from the absence of numbers highlighted either red or blue, for being anomalies, few monthly extremes occurred that decade. Moving on to the late 2000s and into the 2010s, this spreadsheet shows more up-to-date data for 2007 to 2020. It is important to note here that this data was collected by Derek once he had moved to Stoke Cannon. This village sits on the lower part of the River Culm, which enters the River Exe just south of the village before entering the city of Exeter. It's about 7 miles as the crow flies east of Crediton, which is the town where his father collected the data. Crediton sat on the River Creedy, the tributary that feeds into the Exe from the northwest, and it sits in a slightly different hilly terrain compared to Stoke Cannon, which is more rural and on the floodplain. When comparing data sets, it's important to consider these differences to not make assumptions that it is one continuous data set. Although they are both from such close proximity, they nevertheless give an excellent overall indication of historical weather patterns in this. From 2007 to 2020, you can see far more anomalies highlighted in red for being exceptionally dry months or highlighted in blue for being exceptionally wet months. Looking at the total annual rainfall, you will see the values are also more extreme and occur more frequently. Instead of ranging around 800mm per year, instead you can see values in the 600mm range and as high as the 1200mm range and even above. The very wet years also follow more closely behind the very dry years, and it will be interesting to see if this continues as a trend in the coming decade as well. This unpredictability and the more extreme nature of rainfall between the years could make it much harder for farmers, land managers, planners and so on to prepare and adapt for future weather and climate. Comparing monthly averages for each decade, the numbers highlighted in yellow show that over time the months of March, April and May are becoming drier, by on average more than 20mm per decade. December has also experienced 20 or so years of being drier in the 90s and early 2000s, but in the last decade has returned to again being very wet. There appears to be an indication this might have occurred when there were particularly wet summers on average. Explaining this variability is difficult, and another completely separate challenge. Looking at the Stoke Cannon data for the 2000s compared to Exeter Airport, where the Met Office have their weather station, average monthly rainfall is higher throughout the year. It goes to show that more local and microscale measurements offer a more accurate picture of what is actually going on in the catchment from stream to stream and area to area. Picking out individual flood events from the data has also been interesting to do. to see if there are factors that combine to show that these events in some way could be better predicted in the future. This bar chart shows monthly rainfall in Stoke Cannon for each year since 2000, and the major floods of December 2012 are circled in red. You can see that it was a consistently wet summer and autumn with exceptionally high rainfall in both November and December, leading to the floods just before New Year's. Here is some photography of the flooding that occurred in 2020, more recently. This flood is more difficult to explain from the data, but if you look carefully from June onwards, there is increasingly heavy rain for each alternate month in the run-up to December, suggesting the soil might have never had the chance to dry out. Also, it was preceded by a very wet winter the year before in 2019, with exceptional rainfall in February 2020. Therefore, maybe it was a flood by accumulation. These two different sets of circumstances leading up to the flooding are very different, and that's why detailed data such as this can help pick out those trends and patterns and tell the stories that Since the late 2000s, there are more noticeable trajectories in the data, particularly when comparing seasonal rolling averages. Here you can see a line graph showing changes in rainfall in Stoke Cannon from 2008 to 2020. The blue line shows winter, the yellow line shows autumn, the grey line shows summer, and the orange line shows spring. The amount of rainfall in winters is on average creeping upwards, so they have become wetter over the last 12 years, from approximately 75 millimetres per month for the seasonal average over winter, December, January and February, to 100 millimetres per month now falling. Simultaneously, summer on average has become drier each year within the last 12 years, from an average of approximately 86 millimetres per month to 60 millimetres per month. Spring from a seasonal average over March, April and May of 81 millimetres falling to 65 millimetres. So, wetter winters and drier summers could be difficult for farmers to manage, and more flash flooding could occur when weather conditions have to change quickly between larger extremes. Overall, what we see from Derek's data is that throughout the 1980s and early 1990s, there was far more variability throughout each individual year, but overall monthly and yearly totals were more steady. Now there are much bigger differences year on year, so a wet year will suddenly follow a very dry year, and it has all become much less predictable. Also, overall, it's become a lot wetter, because even though summers are a little drier, winters have much more rainfall in comparison. It's interesting to see these changes occur at a greater speed within the last 2 decades, and it will be important to see whether this continues into the 2020s as Derek continues to take his measurements every few days. These insights and stories would not be possible without the tiny yet frequent and reliable recording of data from our citizen scientists and volunteers.